Hi. So here are the practice problems for section 4. I've given you some formulas that we're going to look at, and again, you can print this out if you want. That way, you'll have some sort of record of it. Because I want to draw the following angles, but I want to just kind of do something before I do that. So we know that one trip around the circle is 360 degrees. Two trips is twice that, so 720. 3 times around is going to be 1080. And 4 trips is going to be 1440 degrees. Okay. Now this will be helpful. So I want to oops. Oh, there we go. Good. Okay. So I want to draw this angle right here. And I see that it's going to be 2 trips around, 720, but not quite 3. So I know it's going to be a negative angle. And so I'm going to go around twice. So here we go. So we're going to go, here, let me just do it this way before I do that. Minus 975, 720. So I'm going to have 55, 250 degrees. I'm going to go around twice plus another 250 degrees. So I'm going to go in the negative direction. So there's 360 minus 720, and then about another 255. So that's going to bring me to about here. Okay, so I'm going in that direction. So that angle right to there is going to be minus 975. Okay, so sorry, this thing's jumping in out of focus. Okay, 45 degrees, it's fairly straightforward. We don't even go around once. We know that from here to here is 90, so I'm just going to go halfway, 45 degrees. Okay, and then this last one, 120. I'm sorry, 1200. That's going to be 1, 2, 3, but not quite 4 trips around. So I'm going to subtract 3 trips, and I get 120. So that's going to be 3 trips around, 1, 2, 3, plus another 20, another 120. So there's 360, 720, 1080, and then another 120, which would take me to right about here. So that would be 1200 degrees. Okay, so I want to convert these angles to radians. So I am going to use this formula right here. So I'm going to have theta radians, or let's put it this way, minus 975 in radians is going to be equal to minus 975 times pi times 180. And I worked this out, and at least I thought I worked it out. Maybe I didn't. Let me do it really quickly on my calculator. So sorry, I thought I had already done this. So it's going to be minus 975 times pi divided by 180. So that's going to give me minus 17.017 radians. So much smaller. Okay. Now 45 degrees to radians. So that's going to be I think that's confusing to write it that way. So I'm just going to write it. The angle theta in radians is going to be 45 degrees times pi times 180. Notice here that 45 goes into 180 4 times. So I know that 4 times 45, I'll write that here, is equal to 180. So I'm going to have 4 left, and I'm just going to get pi over 4. So that's a good thing to remember. You'll see this again. That's 45 degrees. This one over here isn't that important, but I should circle it. And so 1200 degrees, do the same thing. Theta in radians is going to be 1200 times pi over 180. And what I'm going to do, I'm going to keep the pi in there because that's a habit that you'll see, and that's what you might see in WebAssign. So I'm going to divide 1200 divided by 180. And what I'm going to get is 6 2/3. So when I do that, that's going to be 20/3 times pi. So this is important because you often leave pi in when you're doing a radian calculation. It's all here in the formula, and it's going to stay in. Okay, just keep that in mind. Like when you have some, if WebAssign is asking you for, it's not saying round to a decimal, they're going to want an exact answer, so they're going to want you to leave pi in the calculation. So again, we'll have other examples of that. So I want to find the arc length of a 45-degree angle whose radius is 10. So we're using degrees, so I'm going to use the arc length S in degrees. I want to make sure I use the right formula. That's going to be equal my angle, which is 45 degrees, times pi over 180, times the radius is 10. So we will go through all this, do the calculations. I did work this one out. I'm going to round to decimals, 7.854. That would be the length. Now I'm going to find the same thing in radians. I should get the same answer. So I'm going to use the Radian formula right here. So we're going to get, it's going to be equal to pi over 4 times 10. Okay, that's going to be pi times 5/2. And again, I'm going to convert it to decimal, and I get the same answer. Now notice if I had left the pi in here, this would have been a 4. I would have had pi times 10 over 4, move that 4 under the 10, and that would be pi times 5/2. Same answer. Okay, so you should get the same length. It's the same length no matter how you do your computation. Okay. So I have some more practice problems here, and I'm going to convert these angles to degrees. And my purpose here is these are very famous angles. You're going to see them over and over again. And so it's just life is easier in math, or math life is easier, if you can just know that what these angles are in degrees. So I'm going to go through each one, and then I'm going to draw the angles. So this is theta degrees. We want to convert this to degrees, so it's going to be theta radians, pi over 6 times 180 over pi. The pi's cancel. You get 180 over 6, which is 30 degrees. So 30 degrees is the same as pi over 6. Again, you're going to be seeing this over and over again. So what this angle looks like, 30-degree angle from here, so I'll make it kind of small. That's going to be pi over 4 equals 45 degrees. Okay. Okay. I'm sorry, pi over 6. So let's draw that again. We said pi over 6 is 30. So we're going to go about 30 degrees. So about to here. And that's going to be pi over 6 or 30 degrees. Radians preferred. Okay, we'll do the same thing here. Pi over 4, we're going to take the pi over 4 times 180 over pi. You'll see a pattern. Those cancel. You get 180 over 4. We saw before that was 45 degrees when you do the math. So here's what this looks like. It's going to be the halfway point. So that's going to be pi over 4 radians, 45 degrees. Okay. Again, you want to make sure that at some point that you understand that and don't really have to think about it too much. So the same thing here, pi over 3. So our angle is going to be pi over 3 times 180 over pi. Those cancel, you get 180 over 3. That's 60 degrees. Okay. Here, so that's going to be a little bit in the first quadrant to here. That's not a very good picture, but you get the idea. Pi over 3, same as 60 degrees. Okay. Okay. pi over 2. Again, times 180 over pi. Those cancel. We get 180 over 2, 90 degrees. So pi over 2 and 90 degrees are the same. So that's my 90-degree angle. That's going to be pi over 2, or 90 degrees. Okay, let's do a couple more. We want to convert pi to radians. Notice that 2 pi is 90, so pi should be twice 2 pi, which is 180. So I'm going to just put that here. Is it 180? Should be. So let's go through the calculation. We're going to convert it. That's going to be the angle pi times 180 over pi. Yep, 180 degrees. Okay, so this is what this angle is going to look like. It's going to be 180. That's going to be pi radians, or 180 degrees. Okay, got two more. I'm guessing you can tell what 2 pi is going to be. It should be 360. Well, let's go through the formula. So I'll say 360 over here. Let's go through the formula. In degrees, this is going to be 2 pi times 180 over pi, using that formula. Pi's cancel. 2 times 180. Yep, 360 degrees. One trip around the circle. So it's going to be this. 360 equals 2 pi radians. Then we have one more, 3 pi over 2. Again, pi over 2 is 90, so hopefully this will be 3 times 90 equals 270. So let's just go through the formula. We're going to take pi radians, 3 pi over 2, multiply it times that 180 times pi. The pi's cancel. 2 goes into 180, 90. 3 times 190 is going to be 270 degrees, just as we thought. And so this angle from here to here will be 270 degrees, or 3 pi over 2 radians. Okay. So again, there's not a whole lot of computations here. We'll do some more in class to solidify some of these ideas. But the key notion is that these are famous angles we're going to see again. So just kind of make sure that you know them. It just makes life a little bit easier. And again, WebAssign is going to want to have your angles with the pi in them, I'm pretty sure. So get in the habit of doing that rather than converting it. And just one more thing, just these are kind of important formulas. It might be a good idea to save them somewhere so you can refer back to them. Okay, I'm sorry that the thing was jumping in and out of focus, of the autofocus. I apologize for that. Okay, thank you. That's it. Bye-bye.